The next section, which is section 2.3, is talking about the third method for finding the volume, which is the cylinder method. So normally speaking, cylinder method is used when you cannot use the disk method or the washer method. So let's looking at this particular example here. I want to find the volume by finding the region y equal to 2x squared minus x cubed, and then the y equal to 0. Let's pull out the decimal and look at the graph. So this is the graph I have. The green one is the function, and then the purple one is y equal to 0. And we only want the part that the two graphs are enclosed. So we're going to retreat the domain from 0 to 2. So this is the piece we got. And now let's rotate it. Along the x-axis. And this is the three-dimensional shape looks like. We can try to slice them, but if we slice horizontally, we will have a kind of like a washer kind of situation. But the problem is both inside and outside is the same function. We only have one function, y equal to 2x squared minus x cubed. So we cannot really using the washer method. And of course, it's not going to be a disk method. So what we're going to do is we are going to using the cylinder method. We're going to still slice them, but we're going to slice them in term like a cylinder. In the cylinder way, we're going to slice them. So one slice, when they turn it to us, or when we're looking at it from upside down, it's going to be a circle. But if we're going to looking at this slice, because the slice itself is a three-dimensional cylinder, but it's hollow inside. And we want to find the area of this particular one. And what we're going to do, we're going to using the circumference of the circle multiplied by the height. You can imagine you have a piece of paper right now, and then you fold not really folding it, but you wrap it to make a cylinder, and that is the cylinder shape is talking about. This is actually one slice. So we're going to find the circumference of the cylinder, which is 2 pi r. You need to figure out the r, which is the distance from the rotation axis to the slice. From this picture, our radius for this problem is x. The next value we need to find is the h. And h, for this particular problem, is the height from the graph to the x-axis, which is going to be the y, which is 2x squared minus x cubed. This is how we set it up, and now we can start to evaluating them. We can pull out the constant 2 pi to the front, multiply the x and the 2x squared minus x cubed, using the power rules to evaluate it. Evaluate at 0 to 2. multiplied and simplified them. We got 32 over 4 minus 32 over 5 minus 0, which is 2 pi times 8 minus 32 over 5, which is 40 over 5 minus 32 over 5, which is 8. 2 times 8 is 16, so 16 pi over 5. Now let's looking at another example. This one we have y equal to x squared. So the region is bounded between the x squared and then the x-axis. And then we're going to rotate this region along the y-axis to make the three-dimensional shape. So this is the region, and then we're going to rotate it along the y-axis. And here is the three-dimensional shape we got. So we were using the cylinder method. So the region is going to from 1 to 2, because that's the interval, of 2 pi x and that is the circumference, multiplied by the height, which is x squared, the y value of the function f of x equal to x squared. Now we can evaluate it, pull out the constant 2 pi to the front. We got integral 1 to 2 x cubed dx, which is x to the 4th over 4, evaluate at 1 to 2, which is 2 pi times 16 over 4 minus 1 over 4, which is going to be 4 minus 1/4, or 15 over 4 times 2, 30 pi over 4, divided by 2, 15 pi over 2. Okay. Another example we have here, we have y equal to 3x minus x squared. And then the region we're talking about is from this graph to the x-axis. Over the interval 0 to 2. And then we're going to rotate it along the y-axis. So fast forward a little bit. This is my three-dimensional shape, and now we're using the cylinder method to slice it. So the volume is going to be from 0 to 2 of 2 pi r, or 2 pi x, multiplied by the height, which is the y value, 3x minus x squared. Evaluate it, pull out the constant 2x to the front. And multiply the x and the 3x minus x squared. Finding the antiderivative. Evaluate from 0 to 2. Three divided by 3 is 1, so x cubed, which is 8, minus 16 over 4 minus 0. So we ended up with 8 pi at the end. Another example, this time we have x equal to 3 over y. And then the region is bounded between the y-axis and then and this curve. And we're going to rotate it along the x-axis. Let's fast forward to get the three-dimensional shape. With the inside is hollow. Okay, so we're still going to using the cylinder method. You can also use the washer method, but here because of the topic, we will use cylinder method. And you can see that this cylinder is sliced horizontally. So we're going to using dy. And because we're using dy, the radius is actually going to be y. So the height is going to be the h. The height is going to be the x. But we have to rewrite the x in terms of a function y. Now let's find the integral from 1 to 3 of the y value. The circumference is going to be 2 pi r, for this case 2 pi y, multiplied by the height, dy. Pull out the constant 2 pi, and simplify the y and 3 over y, which is just 3. So 2 pi y times 3 over y, which is just 6 pi. Antiderivative is going to be 6 pi y. Evaluate from 1 to 3. We ended up with 18y minus 6, 18 pi minus 6 pi, which is 12 pi as the final answer. Okay, so here we didn't have any example that we are rotating along y equal to 1 or x equal to negative 2. So for here, our r value is either x or y. But you do need to keep in mind that the r value, we do need to find it. That is the radius of the cylinder. So you do need to find the distance on the graph. So if we are rotating along x equals to negative 1, for example, your radius is going to be the x values plus 1 or y values plus 1. So you do need to thinking about how to find the radius. It is not always the case the radius is either x or y. You do need to figure out case by case. Okay, and this is the last video for those kind of voiceover situations. Then starting from the next video, it should be normal.